Hello, everyone. Today, I would like to talk about transformation, no, function transformation. But to do that, I'll first introduce what transformations are, and maybe I'll make a video on function transformation separately. But first, let me introduce you what a transformation is. Specifically, what do we mean when we transform a point from the y-axis? Okay, so for example, I'm going to draw, let's say we got a set of axes like this. That's for the y, and this is for the x, and then that's a y. And then let's say we've got a point in the plane. Let's say this point is x, comma y. And if we want this point to dilate or move away or factor it away from the y-axis, let's say we move it away in such a way that the old point becomes this new point. It's being factored away by k and y. So what this means is we have dilated the point xy from the y-axis by a factor of k. Notice that the y is not being affected when we dilate from the y-axis. The y value here, they are not changing at all. So just keep in mind over that. Right. Okay. So that's mean I'm going to label this new point as x dash and y dash. So we know that by just looking at the diagram, we know that x dash is equals to k times x, and then y dash is actually equals to the original y. So there's no change in y, no change in the y, but there's a change in x because we are doing moving away from the y-axis. So that's basically what happens when we transform from the y-axis. But what I want to do is introduce in a mathematical form, for example, using a matrix transformation. So let me introduce that. So we're going to say the old point, the new point here, the new point I'm going to label x dash, which is going to be the same as a vector form, x dash y dash will be equals to the transformation matrix times the old x, the old point, right? So how do you find that transformation matrix? Okay, so to do that, we need to introduce the I call them the vectors, the unit vectors. So that's one, specifically this is 0, 1. Oh, not my bad, that's not 0, 1. 1, 0, and this point would be 0, 1. So we're gonna look at those two main points. So let me draw it here again and see what happens. So 1, 0, 0, 1. And we established the rules that the new point under the transformation x dash, sorry, x will become kx and y would become just the same. It doesn't change. So what that means is using that rules, we can do the following, all right? So what I'm going to do is the point under this transformation, right? This implies that the point we're going to have x, y goes to kx, y. So using these rules, so this is the rules. So using this rule, we'll apply this rule on the point 1, 0 and the point 0, 1. So that will becomes k times the x component, which is 1, and the y doesn't change, remain the same, and which would equals to k comma 0, whereas the point 0 comma 1 would become, so k times 0, and the y remains the same, so this gets 0, 1. So the new points up to when we transform the elements, the vectors, the unit vectors 1 and 1 comma 0 and 0 comma 1. 1 comma 0 goes to, I'm going to say here, k 0, whereas the point 0 comma 1, it just stay the same, because the x, changing the x, timesing x by any value was 0 by any value would still give you 0. So 0 comma 1. So the x value doesn't get changed. We know the y would remain the same, but the x value wouldn't change because it's a 0. So those are the new points under the transformation. Now, what do I use this for? Well, what that means is, therefore, if we want to find the transformation matrix T would be equals to, I'm going to label it in the following way, would be T of I and T of J. By the way, I'm going to write I is equals to, this is I, and this is J in the vector form. So specifically, let me write it this way. So I would equals to 1, 0, and J would equals to 0, 1. All right. So what that means is, we know when you transform this, so this would be the same as k 0, and the J change into, see, it doesn't change at all, 0 comma 1. So that's a transformation matrix. So this is the transformation matrix. This is transformation matrix. And so, sorry about transformation matrix. So that is transformation matrix from the y-axis by a factor of k. All right, so remember the factor of k is in the position here. Okay, so this is when you transform this point, the point x comma y from the y-axis by a factor of k, and this is what we get, and the matrix transformation is going to be this. All right, and in the next videos I will show, this has been like 9 minutes or so, so I'll show you the examples in the next coming videos. Thank you.